Products of electrolysis. The products of electrolysis depends on the nature of material being electrolyzed and the type of electrodes being used. Suppose if the electrode is inert, for example platinum or gold, it does not participate in the chemical reaction and act as only a source or sink for electron. Okay, or if the electrode is reactive, it participates in the participates in the electrode reaction. So thus the products of electrolyte may be different for reactive and inert electrode. The products of electrolysis depends on the different oxidizing and the reducing species present in the electrolytic cell and their standard electrode potential. Then moreover, some of the electrochemical process, although that is feasible, are so slow kinetically, that are lower voltage, that do not seem to be takes place in the extra potential has to be applied. So which makes such process more difficult to occur. For example, sodium chloride, that is the molten sodium chloride. The products of electrolysis are sodium metal and the chlorine gas, Na plus and Cl minus. That is here the products of electrolysis, there is sodium metal and the chlorine gas means 2NaCl, like this. Okay. Here we have only one cation, that's mean Na. So here NaCl having, that is Na plus, only one cation which is reduced to anode, which is reduced at the cathode. For example, Na plus electron to gives Na. Then and one anion, that is the Cl minus ion. Here another one is Cl minus ion. So that Cl minus ion to reduce, that is converts to oxidize, that is electron. So here 2Cl or half Cl2. Can is it like this? Half Cl2 means one electron. So during the electrolysis of aqueous sodium chloride solution, the products are sodium hydroxide, chlorine and the hydrogen gas. In this case, besides of sodium plus, that is Na plus and Cl minus ion, we also have H plus ion and the hydroxide ions along with the solvent molecules like H2O. Okay. At the cathode, the competition between like the reduction reaction Na plus aqueous, so this gives Na solid. Here the standard electrode potential is minus 2.71 volt, and for hydrogen, that is H plus aqueous, for acid electron, half H2 gas. So here the hydrogen standard electrode potential for hydrogen is 0.00 volt. Then the reaction with higher value of, that is the E0 value, the preferred, and therefore the reaction of cathode during the electrolysis. So this is the electrolysis, because the higher value compared to the higher value means this. So the higher value is this compared to this is the higher value. So that half H plus aqueous plus electron gives half H2 gas. So but H plus aqueous is produced by the dissociation of H2O molecule. So that that is H2O liquid gives H plus aqueous and the OH minus aqueous. Therefore the net reaction of the cathode writing of these two, that is H2 So H2O, here this H plus cancel, then the remaining is what here, H2O, this and this, sum of this two reaction, H2O and electron, here one electron, here no electron, so that H2O E minus, that is electron, then half H2O H2 gas plus OH minus aqueous. Okay, see at the anode oxidation reactions are possible, means what, that is Cl minus aqueous gives half moles of Cl2 gas and electron. Here oxidation process, so that similarly water molecule, 2 moles of water then gives oxygen gas and the 4H plus aqueous plus 4 electron. Here for chlorine, the E0 cell value is 1.36 volt, and the H2O, this E0 cell value is 1.23 volt. Therefore, the reaction at anode with the lower value of E0 value. This is the lower value, the first reaction higher value, so that this higher value is preferred at cathode. At anode, lower value preferred, that is the E0 cell value, and therefore the water should get oxidized in the preference to the chloride ion. So however, on account of over potential of oxygen, the reaction, which the reaction means, see this reaction is preferred. Okay, so this the net reaction, usually maybe we can write it, NaCl gives NaCl aqueous to gives Na plus aqueous and the Cl minus ion aqueous. Here for cathode undergoes reduction, so that H2O liquid 1 electron gain to gives half moles of H2 gas and the OH minus aqueous. Then at anode, which reaction, that Cl minus ion, Cl minus aqueous, half moles of Cl2 and 1 electron. So the net reaction will be what, the electron cancel, then here any other cancellations are there? No. See the H2O NaCl, okay, NaCl aqueous for this, and H2O, then here the Cl minus and here the Cl minus is cancelled. The remaining thing is what? You have to write the electron cancelled. Na plus aqueous plus OH minus aqueous plus half H2 gas and half Cl2 gas, half moles of, that is half H2 gas and half moles of Cl2 gas. This is the net reaction. So the standard electrode potential are replaced by the electrode potential given by the Nernst equation, that is usually the Nernst equation to take account in the concentration of effect, that is during the electrolysis of sulphuric acid, usually at acid 2 moles of H2O liquid, oxygen gas gives 4H plus aqueous and 4 electrons. Here the E0 cell value is what here, plus 1.23 volt. Okay. Then the sulfuric acid, this is here the sulfate, like 2 moles of sulfate ion, 2 moles of SO4, 2 minus aqueous to gives S2O8, 2 minus aqueous, then 2 electron. Here the E0 cell value is 1.96 volt. For dilute sulfuric acid reaction, for this preferred this reaction, but higher concentration of H2SO4 preferred this reaction. Okay, for dilute sulfuric acid reaction, this reaction is preferred, and the higher concentration of sulfuric acid, this reaction is preferred. Okay, next is batteries. So batteries, what does mean by batteries? That's one or more than one cell connected in a series. Okay, that is called batteries. Okay, suppose single means that is you have to use only cell. Okay, here any battery or cell that we use as a source of electrical energy is basically a galvanic cell where the chemical energy of the redox reaction is converted into the electrical energy. However, for a battery to be a practical use, it should be reasonably light, compact, and its voltage should not vary appreciably during its use. So here usually the batteries are classified into two types. That is, one is primary batteries, another one is secondary batteries. Primary batteries and the secondary batteries. So in the first we will see the primary batteries. The reaction occurs only once, at after use over a period of time battery becomes dead and cannot be reused. That means the most familiar example of this type dry cell, that is Lagrange cell. After that is Lagrange cell after its discovery. Okay, which is used, that is commonly in our transistors and clocks. So the cell consists of a zinc container that also acts as a anode, and the cathode is the carbon graphite rod surrounded by the powdered manganese dioxide and the carbon. For example, a reaction at anode, zinc solid gives zinc 2 plus and 2 electron. At cathode, reduction takes place here. So manganese dioxide plus ammonium ion and 1 electron gives MnO OH plus NH3. See, this is the commercial dry cell consists of a graphite, that is the carbon cathode in a zinc container. The latter act as a anode. Okay, look at this. This is anode and the cathode, that is carbon rod is cathode. Here the space between the electrodes filled by a moist paste of the ammonium chloride, then the zinc chloride. So the electrode reaction are complex, but usually they will write like this. Okay, in the reaction at cathode, manganese is reduced from +4 oxidation. Here the +4 oxidation to +3 state. Here the +4 and this oxidation state is +3. The ammonium produced in the reaction forms a complex with zinc 2 plus ion to give, that is zinc like this, zinc NH3 4 times 2 plus. So this is the complex. So this cell has a potential of nearly there is nearly 1.5 volt. 1.5 volt. So in a mercury cell, for example, the mercury cell suitable for low current device like hearing aids, watch, like this, etc. Okay, they consist of a zinc and mercury amalgam as anode and a paste of the mercury oxide and carbon as a cathode. So the electrode in a paste like of potassium hydroxide and potassium hydroxide and zinc oxide. The electrode reaction for the cellars anode, at anode zinc amalgam, so zinc with mercury and 2 moles of the hydroxide ion to produce zinc oxide and H2O, 2 electrons. Then at cathode HgO, that is mercury oxide, and the H2O, 2 electrons, Hg liquid and the 2 OH minus ion. See, the overall reaction will be what? There's 2 OH minus 2 OH minus is cancelled, 2 electron is cancelled, water molecule is cancelled. Then the overall reaction should be zinc Hg plus mercury oxide, the solid, then again zinc oxide solid and Hg liquid. So this is the overall reaction. So the cell potential approximately 1.35 volt and remains constant during its life, as the overall reaction does not involve any ion in solution whose concentration can change during its lifetime. Okay. Then secondary batteries. Secondary batteries. Look, this is the secondary battery. The secondary cell after use can be recharged by passing current through its an opposite direction so that it can be used again. So a good secondary battery cell can undergo a large number of discharging and charging cycle. So the most important secondary cell is in the lead storage battery. This is like this. The commonly used in the automobiles and the inverters. So it consists a lead anode and the grid of lead packed with the lead dioxide as cathode. Okay, then this is cathode and this is anode. And the 38% solution of the sulphuric acid used for as an electrolyte. Okay, so the cell reaction like anode is lead to lead sulfate, then cathode lead oxide to lead sulfate. At anode lead solid lead, then sulfate ion, that is aqueous sulfate ion, gives lead sulfate SO4 PbSO4 solid and 2 electron. At cathode lead oxide, that is PbO2, then SO4 2 minus aqueous plus 4H plus aqueous plus 2 electrons gives PbSO4 lead sulfate solid and H2O liquid. Here the overall cell reaction consisting of cathode and the anode. So the reaction should be, that is lead solid and lead oxide, that is PbO2 dioxide, then here 2H2SO4 aqueous because of SO4, that is the 2H2SO4 aqueous, then gives 2, similarly this PbSO4, 2 PbSO4 and there is solid and 2 moles of water molecule. So here the electron is cancelled. right? So on the charging of battery, the reaction is reversed and the lead sulfate anode and the cathode is converted into lead oxide respectively. Okay, students. Then the another important secondary cell is nickel cadmium cell, which has longer life than the lead storage cell, but the more expensive to the manufacture. So we are not going to the detailed study of this higher secondary level. Okay, usually the reaction will be that cadmium solid react with sodium nickel, 2 moles of the nickel hydroxide solid to cadmium oxide solid and nickel hydroxide solid, then water. So this is the overall reaction for the nickel cadmium battery.